Okay, so let's get right into it. Every single day, you use apps, you browse websites, you rely on software to get things done. But have you ever stopped to think about the incredible journey a single feature takes to get to your screen? Well, today, we're going to go behind the scenes. We're going to follow one little code change from a developer's keyboard all the way to a live application. So, really, how does it happen? A developer somewhere fixes a tiny bug or adds a cool new button. How does that idea, just a bunch of text, transform into a reliable, secure part of an app you can't live without? It's not magic, I promise you, but it's an absolute masterpiece of engineering. The secret is that it travels through a digital factory. Yeah, think of it like a super high-tech assembly line. Its only job is to take that raw code and turn it into a finished product, safely, quickly, and reliably. So come on, let's take a tour of this factory and see how it all works. Now, in the software world, we call this digital factory a CI/CD pipeline. CI is for continuous integration. That's just making sure all the different developers' code plays nicely together. And CD is for continuous delivery or deployment, which is all about getting that working code out to you, the user. But really, just keep that image of an automated assembly line in your head. Okay, so every journey has a beginning. And for our little piece of code, that journey starts with the developer who wrote it. This is that really cool moment where the creative, human part of the process hands things off to the automated, machine-driven part. So the developer finishes up their work, they save it, and then they push that code to a central spot, a place like GitHub. That single push, that's the trigger. It's like flipping the giant on switch for the whole factory. The pipeline just roars to life, and the automation takes over. And just like that, the code has entered the building. It is officially on the factory floor, and the first stage of manufacturing is about to kick off. This is where the raw materials, the lines of code, get assembled and then inspected for quality and safety. The first machine on the line, let's say it's a tool like Google's Cloud Build, grabs all that source code and compiles it. It's basically translating it from human-readable text into a package the machine can actually run, and we call this package an artifact. So if the code is the recipe, the artifact is the finished cake, all boxed up and ready to go. But wait a minute, we've built our package, sure, but how do we actually know it's safe? How do we know the ingredients we used weren't spoiled, or that somebody didn't sneak something nasty into the recipe? This is our first and probably our most critical security checkpoint. And this brings us to a huge idea in modern security: software supply chain security. See, it's not enough to just check the final product anymore. You have to secure every single component that went into it, every tool, every open source library you used, every single step on the assembly line. You have to be able to trust the entire process, from the very beginning to the very end. So how do we prove our factory is secure? Well, we can use a framework like SLSA to grade it. As you move up the levels, you're not just writing things down. You're using tamper-resistant tools and isolated build environments. The main takeaway is this: the higher your SLSA level, the stronger the proof you have that the software you built is exactly what you think it is, with no malicious changes. And that proof leads to this critical step. Once we've built our artifact securely, we have to seal it. We do this with something called a digital signature. Think about it. An unsigned artifact is like a bottle of medicine with no safety seal. Anyone could have opened it and swapped what's inside. A signed artifact, on the other hand, has a cryptographic, tamper-proof seal. It proves it came from our trusted factory and hasn't been touched since. All right, so our artifact is built, scanned, and signed. It's looking really good, but you wouldn't sell a brand new car without taking it for a test drive first, right? Of course not. It's the same thing with software. It's time to take our new code for a spin in a safe, controlled environment where nothing can go wrong in the real world. Now, before our app can even run its tests, it needs to connect to things like databases or other services. And to do that, it needs secrets, passwords, API keys, things like that. This brings us to the cardinal sin of software development. You ready? Never, ever write a password directly in your code. It's like taping your house key to your front door for the whole world to see.
So what's the right way to do it?
Well, the application shouldn't know the secret at all. Instead, when it starts up, it asks a trusted vault, something like GCP's Secret Manager, for the secret it needs. Secret Manager first checks the app's ID to make sure it's allowed to ask, and only then does it securely hand over the secret, usually just for a little while. This whole process is a perfect example of a core security principle called least privilege. The identity the app uses, we call it a service account, has just enough permission to do its job and absolutely nothing more. It can ask for that one specific secret, but it can't read other secrets, it can't delete a database, it can't do anything else. This hugely reduces the damage if anything ever goes wrong. Okay, we're almost there. Our code has passed every single automated check. It was built securely, it aced its tests, and it knows how to handle secrets the right way. It is now sitting at the very last gate, just waiting for one final step before it goes live to millions of users. And this is the moment of truth. Even with the best automation in the world, we still want a final check from a human. So the pipeline, using a tool like Cloud Deploy, actually pauses and waits. It needs a formal thumbs up from a senior engineer or a manager before it's allowed to push that new code into production. It's the ultimate safety net. And how do we know who gave that thumbs up? Because every single action in this entire journey is logged. From the second the code was pushed, to the build, the scan, the test, and that final approval. This creates a rock-solid audit trail. It's absolutely essential for security, for troubleshooting, and for accountability. You can think of it as the factory's master logbook. And just like that, with the final approval logged, the code is deployed. It's live. Our journey is complete. So as we wrap up here, let's just boil this whole process down into the core security principles we saw in action. When you really think about it, our code had to pass through 5 essential security gates before it could get out the door. And here they are. This is your final checklist, built directly from the journey we just took. We started with a trusted build system and scanned for vulnerabilities. We digitally signed the artifact to stop any tampering. We used a dedicated secret manager and enforced least privilege to run our tests securely. And for that final safety net, we required a human approval and logged every single step for a complete audit trail. Following these steps turns your pipeline from just an assembly line into a secure digital fortress. So we've built an incredibly secure factory. We have a tamper-proof delivery process. The code has arrived safely in production. But that isn't the end of the story, is it? Securing the factory is one thing, but what does it take to secure the application now that it's running live out in the wild? Well, that's a whole other journey.